Test. Attends. Ouais, c'est bon.
Are we ready? Okie dokie. So for those who do not have any laptops, maybe you can sit together with your friends, get together at the tables, and work together. As I mentioned, this session is going to be a practical session. And you have the QR code here. If you want to scan it, you have the access for the slides. Otherwise, we'll send that in the Discord channel as well. So we have everything covered. Okay, session 3, it's all about Cairo. It's about the vanilla Cairo, where we'll walk you through how to get step-by-step started with Cairo. This is almost the final session. So tomorrow we will have smart contracts, which will be given by Charles. And after that, you'll be able to claim the SPOC, which is basically Starknet proof of kudos. It's a nice sort of NFT that you can collect and show it to your friends. Now, the session topics that we'll cover is we'll start with Cairo's meaning and history. So we'll do a little bit of a small theory, and we'll talk about the field elements. And right after that, we'll go into the practical session. We'll start learning Cairo by solving Stark links. And there's some homework left to do if we don't finalize all the exercises. And we'll have the live coding. So, Cairo, it's a little bit confusing. Like, it's a confusing name. It could mean that, I don't know, you maybe heard of it. You maybe even went to it for a trip. Or for us, it means something else. For us, basically, Cairo originally referred to a computer architecture, a new computer architecture, which was optimized for these validity proofs, or ZK proofs. And Cairo basically refers to CPU air, and O is added at the end for flair to sound better. But this CPU air is algebraic intermediate representation. So this is what the new computer architecture was called initially. Right? Then the low-level bytecode, which is executed by this CPU air, which is the heart of the Cairo VM, is also known as Cairo assembly, or CASM for short. So this bytecode. Now, the high-level language that compiles to Sierra and then to CASM is known as Cairo. So this is the name that we referred to so far, the programming language, the high-level programming language. But please keep in mind, initially was referred to this new type of computer architecture that was optimized for these validity proofs. The old implementation of this high-level language is now known as Cairo 0. Initially, when this was created, we referred to it as Cairo, but now because we have the new level, the new version of Cairo, which is the Rust-based, the old implementation is named Cairo 0. And now it's currently, the name is deprecated. And finally, if you try to search something on the internet, you're gonna have some hard times coming up with some answers. Because searching what is Cairo, you're gonna have very different results. So the term Cairo, it's very terrible for SEO. So you have to be very specific when you search for something. Usually you can add Starknet, and then the results will improve. Okay. Now let's look a little bit at the history of Cairo, how everything started. Initially in 2018, we have the publishing of the Stark white paper. So this is the proof system that basically lays the ground for all the technologies that we have so far, for Starknet, for Cairo, and everything else. Initially, this was created by Starkware, by Eli Ben Sasson, the inventor and creator of Stark's proof system. Then in 2019, we have the creation of the Stark X. If you remember from, I think in the first session we mentioned about it, is this scaling engine that is powering projects like Immutable X, DYDX, and so on. And the first version of Stark X was basically hard-coded polynomial constraints written by hand. And this was feasible back then because the features that we needed were limited, and we basically needed perpetuals and trading, and it made sense. But after a while, there were more features. We wanted to add more features to it and make it more flexible, and the need of a new programming language was needed. So this is where the creation of the programming language Cairo took place in 2020. As I mentioned, back then it was referred to Cairo, but now we refer to it to Cairo 0. And the first version of Cairo 0, the first purpose of this was basically to rewrite StarkX to give it more flexibility to add these new features. After that, in 2021, we have the publishing of the Cairo white paper. So this is not only the programming language itself, the provable programming language, but also the Cairo VM. And shortly after that, in the same year, we have the creation of the Starknet network, which basically allows you to create smart contracts and deploy them on Starknet with the help of Cairo. And finally, in 2023, we have the release of the new version of Cairo, Cairo 1.0. This is the Rust-based syntax, and we just now refer to it as Cairo. So a lot of things happen, but this technology is relatively new. It's started 6 years ago, and we've come a long way so far. Now, just to give you an analogy how Cairo is for Starknet, you have to think about Python, which is basically a general programming language that allows you to create programs and scripts for data analytics and so on. And Django is basically a set of specialized libraries for Python that allows you to create statical websites. So the relationship between Python and Django is the same as with Cairo and Starknet. Cairo is basically the general purpose programming language that allows you to create provable programs. And with a set of special syscalls and libraries, you can deploy smart contracts on Starknet. So you can write smart contracts with Starknet. So this is the relation between Cairo and Starknet and Python and Django. Now, field elements. So this field elements is a new feature to Cairo, something that you don't have in Solidity. And we have the short reference for field elements as felt. In Cairo, we have the default type is this field element, felt 252, and it's not an unsigned integer 256 as in Solidity. Now, if you compare these two, like in Solidity, we have the default type unsigned 256, but there's quite a big difference between these two features. First, if you look at their size, the felt 252 is smaller in comparison to the unsigned integer 256, and second, it's a field type element. So this brings some interesting properties to it. A felt can be represented between a value of 0 and p, which p is basically a large prime number. The large prime number is how the Stark's proof system works. So if you want to find out more about these large prime numbers, definitely check out the white paper. But basically, this large prime number can be computed by that equation. But in essence, this equation, or the result of that equation, it's smaller than a 2 to the power 252. So this will fit into a 252 bits in storage. Now, as I mentioned, it comes with some interesting properties. So when you're trying to do arithmetic operations, all of them in field elements are represented by modulo p. So if you're doing, let's say, an addition, it could overflow. So if you have this large prime number, exactly the large prime number, and we add the +1, it will overflow and will wrap around and will start from 0. That's basically the concept of overflow. And we have also the underflow, which basically if we have the number 0 in our storage in a smart contract, and then we subtract 1, then it will underflow and it will wrap around and will be represented by this large prime number. Now, where it becomes interesting is when you're doing integer division. It's not your standard CPU integer division, where if you divide 7 by 3, it could be either satisfiable or unsatisfiable, depending on the use case. So if you have 7 divided by 3, it could be equal to 2, and it could be satisfied or unsatisfied, depending on the outcome. The thing is, with felt division, this will be always satisfied. And how felt division is represented, so if you have 1 divided by 2, again, these are field elements, this will be a surprising result, so it's going to be represented by p plus 1. So p, we have this big polynomial number, or sorry, large prime number, and it's divided by 2. And it won't be 0 or it won't be 0.5. So this result will be quite big in this term. It's not an error of the system. This is how field element works. And again, if you want to dig deeper into the field elements and how these operations work, I would recommend the Cairo white paper. Next up, let's say that we have these underflow and overflows, right? So if you want to create a smart contract, using felts might be an issue. And for this, we have these signed and unsigned integers that solve these underflow and overflow problems. And these are represented, so the unsigned are represented from U8, U16, up to U256. And then we have a generic unsigned integer, which is usize, and the default type is U32. We have also support for signed integers in Cairo. So these are, again, from I8 until I128. But currently, they're not supported on Starknet. So you can write them in Cairo, but if you deploy smart contracts on Starknet, they're not supported. You're going to have overflow and underflow issues. So far, so good. Feel free to raise hands. Again, it's allowed. Okay, so that's about the theory side. We looked at the history. We looked at the felt types. Now we are ready to get into some interactive tutorials. So initially, the plan is to learn Cairo by using Starklinks, which is an interactive tutorial. Its idea comes from Rust links. For those who are familiar with the Rust programming language, it's something like that. Initially, this was created by Shrami, the guy with the glasses, and then this project was taken further, and an web application was created based on this, and this was created by Damien, the other guy from bottom. And this project is maintained on OnlyDust, so if you're looking to contribute and help, again, OnlyDust is a great platform to start your developer journey, so you can check it out there. As for live coding, what we'll do is we'll basically go to the Starklinks app. You can connect your GitHub account, and I would recommend to do so because it saves your progress, so you're able to progress throughout the exercise, even if you're disconnecting. And finally, what you have to do is basically read the task, see what we need to do, and then compile the code, and if everything works well, we can move to the next step. I'll aim for this session to solve half of the Starklinks. We'll see how this goes. And what we don't solve here will probably be as homework for you. As homework, you have to solve until the Starknet exercises. So the Starknet exercises deals with the smart contracts. So the smart contracts, if you remember, we'll do tomorrow. After we finish tomorrow's session, you can resume these exercises. But feel free to try them. I won't stop you. Okay, I think we're ready to start. So everybody is ready with their laptops? Okay. So if you have this presentation, you can go to the link that I have here, the Starklinks app, and it will open this web app page. If you don't have access to the presentation, you can go to starklinks.app, and you should be able to get access to it. It looks like this, and we'll hit the start coding. You should connect your GitHub account. If I connect my GitHub account, my progress is saved, and I want to start from the beginning. So I'll just disconnect, clear my cookies. You don't have to do this. And now I'm able to start from the beginning. But if you want to save your progress, make sure to connect your GitHub account. Okay, so for the first part, we have intro 1. This is a nice introduction to Cairo. So in this case, you don't have to do anything. What we see here on the right side is basically a main function. It's an empty function, but this is how you write the function, is the fn keyword, and the name of the function, you have the parentheses and the curly brackets. But in this case, this function works correctly, and you just have to hit compile. Are you guys solving? Are we solving together, or how do we go? Okay. Okay. Now let's go into the intro 2. In here we have just an empty canvas. So to make this compile, what do we need to do? Yeah, exactly. So we just create the main function again, like an empty main function. And then we hit compile. Now, each exercise will teach you something about Cairo. Yeah, go ahead. So the usize can mimic any type of size. The default type is set to U32, but it could take any type. So every exercise will teach you something about Cairo, and as we dig deeper, the exercises become more challenging. Okay, so variables 1. If you're stuck somewhere, you can hit the get hint button, and then here you'll have some information about the current exercise. So here we see the declaration on line 2 is missing a keyword that is needed in Cairo to create a new variable binding. So how to do bindings in Cairo is we use the keyword let. Right? So maybe in other languages you have other def or whatever, I don't know exactly. But in this case, if you want to create a variable binding, you do let, and that's how we create a binding. So what happens here? On line 2, we create this variable x, and then on line 3, we use a print ln, which is a macro, and this will print my result. But because I'm compiling it, it just compiles, it doesn't actually run the test. Cool, now let's see. I'm trying to compile this, but I might have an error. Any one of you might know why? Yeah, so we declared x, but it doesn't have any value to it. So we have to assign something to it. And I think we can assign the value 10, for example. And then we try to hit compile. And it will work. Okay, we have reached variable 3. So in this main function, we have on line 2 let x, and we see something additional here. So we have the felt252, which means that we define x to expect a data type of felt252. So this is how we set x to expect a felt252. You can change this to other data types, so if you want an unsigned integer or Boolean or whatever, but we'll see that in a second. Okay, I'll try to hit compile. It won't work, I guess. And it's again the same situation because in the previous exercise we didn't assign a value to this particular variable. So let's do 0. Okay. just a temperature check. How am I going too slow? Am I going too fast? Compiling? And in the back? Okay. For those who solve the exercise, feel free to hop further and then check if you can solve it. I'll go to variables 4, and let me try to hit hint. Maybe I get some information here. And in this hint, it says, in Cairo, variable bindings are immutable by default. So this is one important aspect. Whenever you define a variable, it's immutable. You cannot change it, and that's it. Well, we're trying to reassign here a different value to x, and there's a keyword we could use to make this variable binding mutable instead. Any of you know what's that keyword to make it mutable? Yeah. What? Yeah, it's mute. So I think this is similar in Rust. Rust might have the ampersand, I think, or something like that. So to make this variable mutable, which means that we change its value further, we have to say let mute x equal to 3. And then you don't have to change the line 4 because here we're reassigning the number 5. I'll hit compile. And we're going to variable 5. I'll let you guys see it, maybe look over it, and I'll get to it in a second. Okay, so how many of you are familiar with the concept of shadowing? You? Can you say what it is?
So you're going to put some braces around the second part to make it like the second scope?
No.
No?
No.
Maybe it's about reassign variable?
Yeah.
Yeah.
In a sort. So basically shadowing, it's kind of like you overshadow the previous variable that you've declared. And to do this in Cairo, use the let keyword. So if we read the hint, it says we already learned about how to make immutable variables mutable by using the special keyword. Unfortunately, this doesn't help as much in this exercise because we want to assign a different type value to an existing variable. Sometimes you use existing variables names because you're just converting values to different types, like in this exercise. So in this case, to do the shadowing problem, what we do here is we redeclare the variable with let, and then this would shadow the previous variable. So in this case, we have a unsigned 8, but then we overshadow this with the new value 3. So we hit compile.
By default, what's the data type of the new?
Yeah, a good question. We'll reach that in a second, but if you go back to our presentation, Cairo's default type is felt252. So if you don't declare the data type, it's going to be a felt. And you'll see here that this, if we haven't said anything, this will be a felt. And then felt can also be represented by these strings like this, and this is also felt. And if I hit compile, it should work. But maybe the exercise will complain that I've changed something. But we'll get to this in a second. These are something called short strings, okay? Now, next exercise, we notice that we have constants. Yeah, question. Got it. So in this, thank you. If the compilation works correctly, then it means that you solved the exercise. If you follow the instructions, but if you want to test actually, then you can write tests, right? So in this case, I would write a different function. We'll see this in a second. We'll have more exercises throughout, but basically we have test functions that test the actual function that it returns the exact number that we're looking for. We'll get to that in a second. Okay, so what do we have here? We have constants. Do you guys know what's the issue if I compile? Yeah. Correct. So each constant has to have the data type defined. And so there are, I think, 3 things that you have to know about constants. You have to declare the data type. They're immutable. Even if you assign mute to them, it's going to throw an error. So constants are always immutable. You cannot change them. And finally, as a good practice, notation practice, you always write them in capital letters. Okay? So let's see. Initially here, let's add fell to 52. And then here, there's another way to assign a data type. So you have the number 3, and if you have the underscore, you can say what data type is this. So in this case, we're passing 3 as a unsigned integer 8, and I'll say that this is a U8 as well. And let's hit compile. Okay. Everything going well? Going too fast, too slow? Okay. Now, are we reaching the primitive types? So if we notice that in the main function, now we are looking at booleans. And on line 4, we have let is morning equal to true. So this is a boolean. And then we have an if statement that checks that if indeed it's true, so if is morning is true, then print me the good morning. Otherwise, on line 9, we'll have to define something there because it's incomplete. But on line 10, we'll see that we have is, if is evening, so it's asking, is this true? And if it's true, then print me good evening. So I think we're reaching the is evening time, so I'll say, I'll declare a function, a variable here, so is evening. And I'll say equal to true. And notice that at every end of the line, you have to use the semicolons. That's how we notify Cairo that the line is finishing. And then I'll hit compile. Again, you can use the get hint. If you, oh, I don't have hints this time. And also, this is a good practice to use the Cairo book, which I haven't touched yet, but let's say you have a question regarding shadowing, right? And then you type in shadowing, and then you can have here more information about what shadowing is and how you basically overshadow. At the end, you have some quiz as well to kind of like test your what you've learned, and it's a really good documentation to learn this by going between each other. Now, let's see primitive types too. So now this is a little bit more complicated. We see that as we go further and further, more code appears, so it really takes you from like nothing to more complications or more complex code. Okay, so as I mentioned, I briefly mentioned about felts, and then there are also short strings. I think 2 months ago, something like that, before introducing of the byte array, we only had short strings. And short strings are basically 31 characters. So a short string can be represented by maximum 31 characters. And the reason why is that is each character is 8 bytes, and only 31 characters fit in a 252 byte. It's roughly 251 point something. So if we read the description, a short string is a string whose length is at most 31 characters because each character is 8 bytes, and therefore can fit into a single field element. If you're gonna go over it, you're gonna have a compilation error. Short strings are actually felts, so they're not technically real strings, and they are written as the single quote. Long strings, which are represented by byte arrays, they are represented by the double quotes. You can see them here. So these are the long strings. This is a byte array, you see? And then this is a short string, aka felt. So let's hit get hint to see if we have something. God damn it, I'm not lucky this time either. So we see that we have on line 7, we assign mutability to my first initial, and then we assign C, and then we have a function is alphabetic, and then here basically there's a function, where is it? This function is alphabetic, and then this function checks if indeed the character that we passed is alphabetic, and if it's alphabetic, it's gonna return me true, otherwise it's gonna return me false. And then if this is true, it's gonna print alphabetic, otherwise it's gonna go to a different function called isNumeric, which is lower, and then here checks that if this certain character is indeed numeric. Now, the first part, we don't have to touch it. We have to go to line 20, and then in this line, it says, finish this line like the example above. What is your favorite short string? Try a letter, try a number, try a special character, try whatever you want. So, to see what variable I need to create, if you look at this function, so we have this is alphabetic function below, and then I pass the variable your character. So I have to create the variable your character. But because I have a reference, I have to make it mutable. And remember, we're doing this because of the ownership model. Whenever we're passing it to the function that references it, it will automatically return the ownership of the variable. That's how, like, this is something borrowed from Rust as well. Okay, so do you guys have any favorite character or something like that? Or number? 42? 42, let's put 42. Sorry? I go up? Oh, semicolon, yes, true, yeah. That's correct, yeah. I always keep forgetting that. I think in other, what do you call it, like in VS Code, if you work in TypeScript or whatever, it's always added to the end, so. Okay, so, thank you. Let's hit compile. And we managed to finish this exercise as well, so correct. Any questions so far? Yes? So, in this case, this function doesn't necessarily changes the variable, right? But if this will change, then I need to pass the mutable reference, right? Because we're changing the variable. And if I change the value of the variable, I need to pass back the ownership function. Because how the ownership model functions is that I'm calling a function, I'm giving it my variable, my ownership of the variable to the function. And if you say ref, it will automatically return the ownership for you. Otherwise, you will have to manually return the ownership. But this is coming from the Rust model. They're inspired by the ownership model because everything in Cairo is immutable, and that's how we handle these variables and mutability.
En gros, du coup, la meuf, elle était en mode, ok, bah non, fuck, on va pas vous faire la com, on s'en bat les couilles. Abiraslav. Et du coup, elle a dit, mais vas-y, on reste chaud.
Yes, so
Plus, tu vois, nous, on a rien à...
Cairo, it's a linear type system, so
Ce qu'elle a fait, c'est qu'elle a envoyé...
every variable has a single owner.
Elle a fait un formulaire, un code. Et elle a dit, ouais, est-ce que vous êtes un...
A value can have multiple variables, but then a variable can only have one owner. And when you're working it with functions and you're passing this variable to the function, if it's changing its value, you have to you have to make it mutable. Hence, you're passing the ownership to the function itself. And then if you're using the keyword ref in the function like here, we will automatically return the ownership to the variable because we're using it here in this function. Like if this doesn't changes anything to the variable, but if I would say character +1 or something, I'll change the character, I'll mutate the value. So that's basically it. But if you want to dig deeper, you can come to the Cairo book, and then we have this ownership segment, and then you'll see exactly what happens. We have also the variable scope that basically if the variable goes out of scope, it's automatically destroyed. That's how Cairo works. Okay. Any questions? So, yeah. Ah, nice. Okay, let me show it to you. So this function, what it does is that, remember, we're working with felds, right? So 42 is a feld. And we're passing here, so this function says, if character is bigger or equal to 0, then go inside, and then if this character is smaller or equal to 9, then return true. Now, let me think about, what was it, raycast? Raycast. So I have a converter here. And if I convert the variable, let's say 42, it's going to be a felt 42, right? That's the actual, like 42 is 42 as represented as felt. Now, if I convert 0, it's going to be 0. If I say 9, it's going to be 9. Is 42 smaller than... It compiles, but actually it's not, it's going to return false either way. So the reason why it compiles is going to be, so this is going to be the actual result. So you have to have only one number. So you say 4, but I added 42 because of the, but in this segment, we'll go to neither alphabetic or numeric. But how this works is that, let me show you to the alphabetic part, because that makes more sense. So let me see if I can bring this up again. Raycast. So if I put A, the file will be 97, right? So automatically behind this, we'll say the character that I passed, is it bigger than the felt 97? That's what A represents in felt. And then if I put Z, this is going to be 122. So it's a range check. Now, if I put my character H, this automatically will be caught in this range of felts. So it's 104. And then if you remember, this is, I think, 90 something, and then this is 120. So it's going to fit into this. So technically, again, these short strings behind the scene, they are felts. That's how the whole thing works. Okay. Now, let's see what's this. So primitive type tree. Deconstruct the cat tuple to call print on each member. Do you guys know what the tuple is? Yeah. Yeah. Well, what it is. I think that's a dictionary. So, yeah. Yeah, so it's basically a collection of different data types. And one thing interesting about tuples is that once you define it, you cannot change the size of the tuple. So once you defined it, it sticks like that. It can hold any type of data type, so you can have booleans, you can have unsigned integers, whatever you want to. So on line 2, we have let cat equal to Furry McPherson, and this is a felt, because it is represented by these, I forgot how to call this, semicolons, exactly. And then we have a 3, which basically by default, all of them are felts. Now, on line 3, we kind of like have to deconstruct this tuple because we have to extract the name and the age. How to do that? Let's see the hints if it gives us something. So you'll have some hints here how basically it works. But to deconstruct the tuple, you can say something like this. So you put the parentheses, and then you say name, and then you say age, and then you assign the tuple. And this is how we basically deconstruct the tuple, and we'll get the name and the age from this tuple. So again, tuples are basically a custom structure that holds different data types. You can define any data types in it, and once you create the tuple, you cannot change its size.
How can I access to only one data in my table?
You have to deconstruct it, and if you don't use something, I guess you can use some like underscore or something like that. But then I have an error because I accept the, I'm looking for the age. Okay. Now, things are getting more interesting. So we have primitive type 4. The task is modify the integer types to make the test pass. Learn how to convert between integer types and felts. Let me just try to make this readable. Okay, so if we look at this, maybe let's hit the hint first. So there are multiple integer types in Cairo. You can read about them in the Cairo book. So again, it's good to go hand in hand with the Cairo book and the exercises if you have questions. What we need to do is basically we have to sum two integers together and get the result. And the result is bigger than the biggest integer of this type. So if we see here some big numbers, we have two U8s, and then we're returning a U8 here. So in this case, we might have a issue because we might overflow if we're passing two big numbers. And I know like you asked me how we test this. You see like these are the test functions, and this is how we actually test the functions that are working correctly. And inside here, you see that we add two numbers, which is 255 and 255. And this is obviously, it's out of a bound of an unsigned 8, so it's going to be 510. So what to do here? What to do? We have something called casting. So casting means that you're able to take the data type of the number and cast it into another data type. And there are two different ways of casting. You have, or two different functions of casting. We have into, and then we have the try into. Now, these two functions are different. The into, you're using it when you're 100% sure that the data type you're casting into fits into that data type. So what I mean by this, if we have an unsigned 8, and if we cast it into a felt 252, it will always fit in that. It will always fit. But if we go other way around, so the felt 252, we cast it down to unsigned 8, we're not sure that this might fit. So we'll have to use the try into, because the try into will return me an option that I'm able to handle in case of this is correct. If it matters to cast it down, it will return me the value. Otherwise, it will gracefully give me an error. Okay, so let's see what we need to do. So first, I have this function convert to felt. What do we need to do here? Yeah. And how we do that? No? The into. We can always fit U8 into a file to 52. So we'll use into because we're sure that that will work. You can use try into as well, but I think you'll use some extra resources for that if you're using that. So in this case, I'll say x into, and that's it. One interesting thing, I mean, if you're coming from a Rust background, this might be familiar, but you'll probably ask, like, why I'm not returning the value of this number. This is how I return it. I don't have any semicolons, and this will automatically be returned. Otherwise, if you specifically want to return it, you have to say return, and then you'll have to say x into, and like this. Right? This also works, and this also works. If you don't add the semicolons at the end, it will automatically return it. And now we'll try to convert a felt to U8. So what are we doing here? Try into, yeah. Because we're not sure that the felt to 52 might fit into an actual U8. So we'll say x, try into. And now the thing is, whenever you're doing try into, it's going to return you something. It's an option, right? And I mentioned that option, it's either the value itself or the error. So to actually get the value, we have to unwrap that. So to get the actual value, we'll say unwrap. And that's how we extract the value from the method.
What happens if there is an error?
In this function, let's see if we have an error. I don't think we test it, but basically what you can do is that you can do some sort of a pattern matching, which is, I think, in the following exercises. And then you can match based on if you receive some result, then you return that. Or if it's an error, then you can gracefully handle that error. Otherwise, it's going to be a compilation issue here, because it's going to say error, and you didn't handle it correctly, right? So, but I think in this case, we're not actually testing the error, because we're just learning the casting types. Okay? Now, I'm not done here, so I still have some issues here on the test side, so let's see what we need to do. So modify this test to use the correct integer types. Don't modify the values, just the types. See how using the U8 suffix on the number lets us specify the type. Try to do something with other integer types. Okay, so maybe we make this a different data type. So we'll say the bigger version, so U16. Let me think. Some big two numbers. Let me try to see if this works. So I'll say U8 initially here. And I'll let the other one U16. Or no, a felt. I'll let it a felt because we built this convert to felt. And I'll want to use the felt. So for that, felt to 56 to 52, or you don't have to specify it. It will be default as a felt. So to use it as a felt, I'm going to change this function. So this is modify the types of this function to prevent the overflow and summing big numbers. So I modified the return type. And then I can say convert to felt, and convert to felt again. And let's see if this actually works. So I'm passing two U8s. I convert these to felts, and then I'm returning the result as felt. And then the data type expected here is a felt. So let's test it. And it works. So you can do something else as well here. So in this case, you can say unsigned 16, but then you'll have to create a function to cast it into U16, right? And then you can convert these two numbers into, instead of felts, you can convert them, you can cast them into U16. Yes, it's good because initially you have U8s here, right? So here you had U8, and when you're summing two big numbers, so the limit of U8 is basically 255 because it starts from 0 to 255, and if you sum these two numbers, it will overflow, and you're gonna have an issue. Yes, because basically they don't match the data type. So I'm returning the felt to 52, but then here I'm comparing it to U16, and it's going to throw an error. Yeah? Is this going well? Yeah? I can come down.
And I'm curious why I don't need to mention anything here.
So the question is why you don't have to mention is because if you don't have the semicolons, it will automatically return it.
And how does it automatically detect that it's U16 and not something else?
Because when you return, it looks at the return type, right? And because the return type is U16, it will automatically convert into that. So that's how it works. So it compares the return type, and then if you cast it into the return type, it will expect. So whenever you return something, it will expect this, okay, and it will automatically convert it to U16. So just for the sake of example, let's try to convert this to U16 as well. So I come here. I'll modify this to U16. And instead of converting it to a felt, you can say into. Right? And now the one change that I have to do is basically in my test, you have to make sure that you're expecting 16 here, like the data type that we have. So we'll try to compile this or test it. And again, it works. Because we're expecting the data type, the return data type to be U16. And then when we're casting it, it will cast it to that data type. Make sense? Good? Ready to go for the next one? Okay. Operations. So integer types implement basic comparisons and arithmetic operators. Felt 250 operations should be avoided where possible, as they could have unwanted behavior. And we've seen that in the presentation. When we're doing arithmetic operations with felts, it might overflow, it might underflow, and you don't know. You don't have protection. So whenever you're doing operations, always use the unsigned integers, because they always have protection of overflow and underflow, and you can gracefully handle this. Also, division, it's something unexpected. So let's see what happens here. So we have a polynomial function. We have x and y. The u size is, the default is u32, but this can take whatever. And we return a u size back. So we have to reconstruct the polynomial function. In this case, we see here at the top, we have x to the power of 3 plus y minus 2. You can also press the hint button, and you have a small hint here. Again, it references to the Cairo book. Make sure to check that out. Actually, let me check that out now. Go to, because we want to also investigate what type of operators we have. You might be familiar from other languages to do something like this. So x to the power of 3, right? But you have to be careful, because currently Cairo doesn't support this. This will mean something else. So if you go to the operators, and we see here in the table somewhere, here, this operator, I forgot what the name is, but this is basically a bit XOR, so it's an expression. So it doesn't represent to the power of 3. It will be an expression. So you'll do bitwise exclusive OR. So it's totally different. That's why it's good to navigate the Cairo book and to see how this works. So obviously we'll have to do the traditional way. It's a bit tedious, but it's x times x times x, I know, plus y and minus 2. Okay, and then, oh, I think I did a mistake here, so I shouldn't have changed this in any way. What happens is that res, short for result, so for that I'll create a variable res equal to, and then I'll pass that function here. And then on the last line it says res, which automatically will return the variable. But if you want to return it as well, you can explicitly say that, and then you just have to add the semicolons. This also works. Okay? Let's try to hit test. I changed it again because I shouldn't change this. But just for the sake of showing an example. So far, so good? Now, let's go to operations number 2. So Cairo has native integer types. We talked about this shortly. These are the unsigned 8, U32, up to unsigned 256. And then you have the usize, which support more operators than felts. And always watch out for the overflows, like in the last test. So we had an overflow issue there. So whenever you're doing arithmetic operations, you use the unsigned integers and nothing else. So to do modulus, we'll define result again. Do you know how to do modulus? Like, what's the operator for that? What? Ampersand, right? Yeah. So we have x and then percentage y, and then this should work. And then if this is like these numbers will result in an overflow and underflow, it will automatically be detected. And you want that, because if you're an engineer, or if you want to develop a smart contract that handles DeFi and billions of dollars, this might be an issue, right? So you need to be really careful about this. Floor division, we can do that with these unsigned integers. So let res, and then this is your typical division. In other languages, you have this slash, which is represented as division. And then the multiplication is pretty straightforward. So we have let res equal to x times y. And then here we see that if you're interested in how these tests work, they test the modulus, the floor division, the multiplication, and then here we see that we have an overflow situation here, and if it overflows, that means that we integrated correctly, and it should panic. So if it panics, that means that this test is correct, because we are expecting this test to panic, right? We're trying to make it fail. And if it fails, we gracefully pass the test. But anyway, this is like what's happening here. It's not part of the exercise, but if you're interested. Okay, let's hit test. Questions so far? Okay, so I'll give you a little bit of time to look at the exercise. I can press the hint button. So this is where we learn about the if statement. So basically, the if condition does not need any to be surrounded by parentheses. You have the if-else condition, and then each condition has to have a curly bracket. In this case, what we need to do is create an if statement based on the input numbers. So let's see what we need to do. Do not use another function, do not use another. So we have to see if A is bigger than B or the other way around. So to do that, we say if A bigger or equal maybe than B, and then as the hint suggested, we have to open the curly brackets, and then inside these curly brackets, we have to return the A, exactly. So we could do it like this, or usually when you're working with if-else statements, it's a bit better to say the return type, because otherwise if you have multiple ifs and else, it's not very noticeable to the naked eye. So I'll say return A, and then say else. And now here you can create another condition, else if, and then check for the other one, but it's not necessarily, because if the first statement is not correct, it automatically assumes that B is bigger, right? So we're just saying else, and then say return B. Let's test it. And then the reason why I said return is that you can have it like this as well. This would also work. But it's a bit difficult to the naked eye to see what happens at every, like imagine if you have like 10 ifs there, it's gonna be a bit challenging. You also whenever you code, you have to think about your colleagues that might read the code, and you have to interact with them. You have to make this as easy interaction or seamless interaction as possible. If number 2. So we have to make it compile. This is the famous bar foo's exercise. So we have to make this function, bar for foo's, and default to test pass. So these tests, we have to make them pass. So let's see what happens here. Complete this function using the if, else if, or else blocks. If physish is fizz, that's a bit more confusing now. So if physish is fizz, then return foo. If physish is fuzz, return bar. Else, return buzz. Make sense? Ooh. So let's see what we need to do. So we check here first for physish. I'll check if this is actually fizz, and if it's fizz, I'm gonna return foo. Now, if that's not true, I'm gonna say else. Actually, I have to close this, and I can say it here. else, and I'll create another if statement, and I'm checking if physics is indeed equal to fuzz. And if this is correct, then I want to return bar. And otherwise, I should return Baz. And now you can, I mean, it makes sense. I forgot the semicolon. It makes sense, but you start to see that it's difficult to see where everything returns to the naked eye. Like if the first glance is like, what? Anyway, so far so good? Question? Yes. Yes, then you'll have to. Here we just have a one condition. You can also get hint. You can see what happens here. You can press the test. We'll go to the next part. And then here we have to compile it. So what happens here? We have a function, but we actually don't have any function whatsoever. So this is basically a function calling another function. And I guess it's pretty straightforward. We have to create another function. I'll create call me. And then this is the same way as we did in the first exercise. We create it just as an empty function, and then we'll hit compile. How are you guys feeling? Do you guys need a break, or we can continue? It's very slow. At what exercise are you? If one? No pressure. Is the compiler the issue, or? Everybody else? Okay. So what do we have here? What do we need to fix? Do I make it bigger? Is it better? Yeah. Yeah, the data type, like we just have the num here, but we didn't assign any data type here. So whenever you're having input variables, it always expects the variable name and also the data type that we expect. So in this case, you can say it's a fell to 52, or you can say anything else. Oh, so you have the semicolons, and only after the semicolons you have to do this. It's a bit tricky to type with one hand and the other mic. So let me just zoom out a little bit. I'll hit compile. So basically what happens here is that in the main function we call the function call me, and we're passing the value 3. And then in the function call me, it expects a variable of data type fell to 52. And then in line 6, we just use the println macro to print this number. But again, remember, these are long strings, these are byte arrays. So I can have whatever, doesn't matter the size, it will always compile, right? So if I would have the felt instead, it will throw me an error because I'm over 31 characters. Just a reminder here. Okay, function 3. What do we need to do? So we just have to pass a value in this case. Yeah. So we can say whatever, 65. In case you have issues, you can hit the get hint. Okay. We go next. Now we have a little bit of more story here. So it seems like we have a small description. So this store is having a sale where if the price is an even number, you get 10 Cairo bucks off. But if it's an odd number, it's 3 Cairo bucks off. So basically you get a discount. Don't worry about the function bodies themselves. We're only interested in the signatures for now. If anything, this is a good way to peek ahead to future exercises. So we have a main function. We have the original price being 51. And then inside here, there's a print line macro, and it prints the actual price. And you'll see here that it's actually calling a function, sales price, and we're passing the value original price. So what do we need to do here? Sales price says if this is even, but I think this is already, is this already fixed? Is it empty for you guys, or? Because I hit compile, it will compile. Ah, signature, yeah, okay, got it, yeah. True, true. So, yeah, true, I haven't noticed it. So basically here, like you have the function sale, we have an input parameter, but we're returning something back. So to return something, you have to say the data type that you're returning. So you always have to say this. If it's unsigned 32, I say let's return an unsigned 32 back. And then let's try to hit compile. Correct. And then basically, like in this case, sales price checks if it's even by calling this other function, and it's a modulus, yeah.
Why did we do not use the red block? Because we changed the value of the price in second.
Let's see, so why don't we original price, sales. So in this case, we're not using it anymore. So if you would use it after this line, you would have to. You have to give back the ownership, but because we just use it once, or consume it once, you don't have to use it. But if you want to reuse it across the whole program, and you want to keep the reference or the ownership to that variable, you'll have to use this. In this case, we're just creating a variable here, and we're just using it here, and that's it. But for more code, like if you just continue using the original price, you will have to. Now, let's see quizzes. So, hope you guys like quizzes. So let's see what happens here. Mary is buying apples. The price of an apple is calculated as follows. An apple costs 3 Cairo bucks. And if Mary buys more than 40 apples, each apple only costs 2 Cairo bucks. So what we have to do is write a function that calculates the price of an order of apples to give the quantity bought. And we don't have hints. So I'll give you guys a couple of minutes to look at it. And you can call me if you want help, like tell me if you... So how's it going? Good? So let's get back to our apples. So we have to calculate the apples, right? So what we have here, put your function here, right? So so initially I think I need to have an input variable because we're passing some apples, and we'll say apples, and this should be U32. And then we'll return something back. So I think that's going to be the actual price. So let's say it's still U32. Let me close this. So if Mary buys more than 40 apples, then we reduce the cost of an apple to 2 Cairo bucks. If not, it's 3. So if apples is bigger than or equal to 40, then we get a discount back. So apples times 2, else, and then we have curly brackets. We're just gonna reap Mary off. We're gonna say we're gonna give you to the bigger price. So it's 3 Cairo bucks. Let's see if this works. It doesn't. So it's not equal? More than. So we're not going to give Mary, when she buys 40 apples, a discount. Okay, got it. Yeah, makes sense. Cool. So this is the quiz 1. And you notice that as we progress through the exercises, they're getting more interesting and complicated. You have, I think, over 50 exercises, so it's quite nice. It's interactive, and you also have hints. So now let's see what happens here. Yeah. Yeah, so initially everything is felt to 52, but if you define it as U32, Cairo will be able to automatically cast that into, because everything from felt to 52, so Cairo will automatically be able to find that and do the conversion for you in that sense. So, but if I will pass here obviously a bigger number, so let's say bigger than U32, then I'm going to have an error, right? Yeah, you can. It's up to you. But again, it's not. You weren't compiling?
Just like this. So it turns forever, and this is when you didn't compile.
Let me do it on my end. So let's test it with faults, actually. Let's see. Okay, it's because we're doing this check, like if it's bigger and to actually make it work, you have to create your own implementation of it. But if you want to just pass this test, you'll have to use an unsigned 32, which are already having those implementations in this case. Okay, I'll do a couple of more exercises, maybe the loops, but and then we'll probably have a short break and we'll have people from Pragma have a short call or discussion. And then at the end, if you guys want to stick till the end, I'm gonna walk you step by step on how to install the dependencies for the next session, where we'll see how to install everything from scratch. It's crucial for your next session. So let's solve a couple of more, and then the rest of them are homework for you. So we'll look at loops 1. Initially with Cairo 0, we didn't have loops. It was quite tricky. You had to create a function that would help you to create loops. But with Cairo, we do have. So let's see what we need to do. We press the get hint. So if I analyze the test correctly, we have a mutable counter, and then inside this we have the loop function, we have the curly brackets, and then we are incrementing the counter by 1 every time. But the thing is, we don't have any condition whatsoever, so we're just incrementing this counter until infinity. So what we need to do is basically introduce a condition that if this counter is equal to 10, then I'll want to break the loop function, right? So to do that, I'll say if counter is equal to 10, then I would like you to break. And whenever you're breaking, you'll also have to return the variable. Okay. Oh, I don't have to return it now because I'm in the same test, so don't return it. If you're using another function, like I'm calling the test loop with another function, to return the variable, you put it inside the break. But I guess that's the next exercise. Okie dokie. So we have loops number 2. Let's try to solve this as well, and then we can have Pragma to have a short talk. So let's quickly go over. Having trouble solve this, so you can press the get hint button. But let's basically take a look. We have the counter, we have the result, and then we're checking that if counter is equal to 5, how do we return this? Does anyone know how to return this, or how do we exit this loop function? Yeah, that's correct. Always use the break. Okay. Testing. And I forgot the semicolons as always. Okay, in this case, as I mentioned, whenever you're breaking, you do have to return the result as well, right? So to return the result, you have the break, and inside the break, you return the counter, and then this let result will be assigned the function that you're returning here. No, because basically loops, you have to break them. You don't return, like you just return. So if you have a, yeah, so loops are endless, right? You have to have a function to check if some certain condition is valid, then you break the loop, because otherwise it will go for endlessly. And if you just put return, doesn't return anything. So you have to break the loop. In if statements, you have to return the variable. Yeah. Yeah. So in this case, because we have, so as you see on line 6, we are assigning a variable result, and then this result is getting this loop function, right? Condition. And then when this loop condition breaks, I do have to return something else, because otherwise the result will be empty. It doesn't know like what it is. And this is how we explicitly return the value of that loop. Like in the previous exercise, we didn't have to put any value. Okay, that's roughly it for the Starknet exercises. I hope you guys enjoyed them. The rest of them is as homework, so the enums, these are getting very interesting, so make sure to check them out. And yeah, I think we can have Pragma have a talk. Are you ready, or? Okay. Okay, so we'll do one more exercise until we get ready. Enums are nice because they're different type of structure or data type. If we look here, we have an enum with the name message. And then inside this, you'll have to recreate these messages. So on main function, we have the message quit, the message echo, the message move, and the message change color. So to do this, you'll say quit, echo, move, change color. And enums are very interesting because I'm not sure if we'll be able to solve all of them, but as we progress, you'll see that you can create different, each enumerator can hold any data type that you define. So for example, for move, it's going to be an X or two data types, X and Y, which is unsigned integers. For change color, we will have 3 different data types. So we have the RGB, so U8, 3 U8s. For echo, it's going to be a message, so that's going to be a felt, or could be a byte array. And the thing is like whenever you're using enums, they have to be, so you can do some interesting things such as pattern matching on them. And when you're doing the pattern matching that you'll see in enum 3, they have to be exhaustive. So that means that you have to use every enum that you've defined in the same order, and you have to exhaust all the possibilities. So you cannot just, do pattern matching on these 3. You need to do pattern matching on all of them. For example, this is a pattern matching, right? You see match, and then we match on the type of the result that we have, and then we have to say them in the same order, right? So quit, echo, move, change color. You cannot have them in different order. You have to have them exhaustive, and these are how the match function works. But I think this is more explained in the enum 3. So let's hit compile. Maybe I confused a little bit here. Okay. Sorry? Yes. Yes. Yeah, so this is how the exercise starts. It starts lightly, and then in the next one, you'll have to assign here. So you'll see that the message now expects to have a felt here. Then it expects to have 2 different values, which are U8s or whatever, and then you have 3, like a tuple, most likely here. So you can assign the data types as well. Okay? Pragma ready? Cool. So thank you all. After the talk, I'll do the installation of the dependencies, but yeah, thank you. How are you? Doing good. Yeah, you? Hey, put it on this.
Okay. Does everyone speak French here? Or, yes. Bon, je vais peut-être faire la présentation. No? Not everyone. Okay. So I'm going to do it in English. Sorry for the French speakers. So I will try to make very informal presentation. You guys just had a 1.5 hour workshop. So I will not bother you too much with a lot of technical stuff. Personally, first a bit of introduction about myself. I'm Matthias, I'm the co-founder of Pragma. I've been discovered the Starknet ecosystem, I think more than 2 years ago. At the very beginning, like what you just did in Cairo was, it was not this. It was way harder. The language was very hard. It was almost assembly. So there was no tooling. It was very hard to do. So be lucky. Right now, you're coming at a way better timing than I was. And so yeah, discovered Starknet 2 years ago. Went at meetups, workshops like you, and mostly fell in love with the fact that you can prove stuff. That's very cool, right? If you're not familiar with blockchain and things like this, the first thing that really ticked in my head was, okay, we can do a lot of computation. Like I can calculate a very complex thing and just give you a small proof that I did it correctly, and you can verify it very easily. Just that thing, I think that if you need to remember one thing about today, it will be this. Like it's a very powerful primitive that offer us Cairo. You can write any logic you want, and any computation, any video game, AI, whatever you want, and because you've written it in Cairo, it's provable, meaning when you run the program, it will generate a trace, and you can generate a proof from that trace, and then verify it. And that's, yeah, I think that's just amazing. That's a few years back, I would not have believed this could be possible. And yeah, so that led us to build on Starknet. And so what is Pragma? What do I do? So there is something in blockchains called an oracle. I don't know if, can you raise your hand if you're familiar with oracle in blockchain? Okay, pretty much everyone, but not everyone, so I will, an oracle, the main goal is how to get non-deterministic data, so off-chain data on-chain, like what's the price of Bitcoin, what's the weather today, who won the Champions League, like all of this, it's not available on-chain. The blockchain can only access to state that is on the blockchain, right? So how can we put that on-chain in a trustless way? So like we want to introduce as little trust assumptions as possible. Otherwise this whole system doesn't make sense, right? Okay. So the solution today that we have live on Starknet, that we built in Cairo, mostly smart contracts. So we have people on the left, financial institution, exchanges, people that have data. So let's say you do trading, you have the price of Bitcoin, you push it to Starknet. So there is a smart contract on Starknet. You will see tomorrow when you call smart contract, you just have a function, publish data. They call this function with their signature, say, hey, I think the price of Bitcoin is this. And then the contracts store this. And then the aggregation happens on the blockchain. So let's say you want the average price of Bitcoin. All of this will be done in Cairo. So you don't have to trust us for the computation. Everyone just push raw data on chain, and then the aggregation of the data happens in Cairo. And that's, yeah, that's pretty much how it works. You just do trustless computation, so provable computation in Cairo to aggregate a bunch of financial data. Could be financial data, could be other kinds of data, but right now, mostly financial data. And that's very powerful. Decentralized finance is a very important topic and one of the main use cases of blockchain right now. On Starknet, you have a bunch of DeFi protocol. So yeah, you have Nostra, Vizu, Avenue, a bunch of people building ways of generating yield, exchanging tokens, borrowing, lending. So DeFi is a very complex topic in itself. We could speak about it for hours, but yeah, just imagine moving money in trust. You remove intermediaries in the traditional finance, and you get decentralized finance. And so right now, pretty much the whole DeFi landscape on Starknet relies on us. Oracles are a very important. Yeah, you cannot have DeFi without oracles, pretty much. It's very important to know the prices of assets, to be able to price these assets as accurately as possible. Yeah, so I will try not to be so long. At Pragma, we do a bunch of stuff. We've been building for almost 2 years. We do mostly Rust. We do Cairo as well. We do Python, JavaScript, many technologies, and we are growing a lot. We are building our own stack to build Starknet app chain. So let's say you don't like Starknet and you want your own Starknet. Well, that could be possible pretty soon. We are trying to build financial models. Yeah, just great thing. If you want to participate in a world where you don't have to trust how the data is aggregated, how financial data is aggregated, come talk to us. I'd be happy to dive more into these subjects. Yeah, there are many interesting things. I don't want to dive too much in the details, but yeah, hope that convince you that building on Starknet and in blockchain in general is I think a very great experience, because it's not only about programming, it's about game theory, finance, it mixes, I think, a lot of very interesting subjects. So that's why I love working in that industry, and that I think it's a great place to be in. Yeah. Okay, that's pretty much it. If you have any questions. I know I was a bit vague, so if you have questions, feel free. No? Okay. Yes? To Russian people? Yes. Is it open? De Russie? Oui. Normalement, oui. Nous, on est tous à des endroits différents. Il y a des Belges, des Français, des gens à Amsterdam. Pour l'instant, on est complètement remote. Donc voilà. D'autres questions? Non. Bon, bah, n'hésitez pas, de toute façon, je vais être là. On peut parler, hein, normalement. Merci à tous.
Thank you very much. Now, I think we can resume our installation part. So let me just connect my stuff here. So, hello. Oh, we're back. So for the rest of the Starklings, it will be as homework for you. See how many of them you can finish by tomorrow, but it's not necessarily to finish. It's a good exercise. And if you think you can step it up a notch, I would also recommend checking out Node Guardians. So I'm not sure if I have this here. I don't have them. But in my previous presentation, you have the Node Guardians. And then this kind of like takes you to another level where you solve more interesting CTFs or puzzles. So give it a try. Usually during the when we organize hacker houses or different types of events, we always ask like, have you finished Starklinks or Node Guardians? It's always a good thing to do this, and it's a nice thing to add to your portfolio. Okay, without further ado, now let's get into preparing for the next session. In terms of dependencies, what you'll need is these 4 types. So initially, you'll need ASDF. For ASDF basically is just a library manager that allows you to switch between libraries seamlessly. So if I want to install something, I can install it a certain version, and then if I want to downgrade or upgrade, I can do that very easy with this. The next thing is Scarb. Scarb is a package manager similar to Cargo, which allows you to compile Cairo contracts, to add dependencies, and so on. And then we have Starknet or Foundry, Starknet Foundry, which is basically coming from Solidity as well. It's the library that allows you to create unit tests, end-to-end tests, and all sorts of cheat codes that are available. And finally, we have the language server available on VS Code. Maybe there are people that are using IntelliJ, but there's also a version for this. Okay, so let's get started. I have my VM here because I'll start from scratch. And now I'll go step by step how to install everything. So initially, I'll have to install ASDF. So let me just grab this link here. And depending on what type of machine you have, you'll have to follow the rules. Okay, so initially, you'll have to install Git. So I'll just do that on my local machine. Is this big enough or no? Let me make it bigger. Okay. Now I have my Git installed, so depending on what type of machine you have, you can install it. So on Linux is apt install Git. Now going back to ASDF, if you're using Mac, you can install it with Homebrew. It's pretty straightforward. You just say brew install this type of thing, core utils and core and Git. If you're using Linux, you'll do this, install Git. For those who are using Windows, is anyone using Windows? Okay, so for that, you'll have to have the Win2 something called, and then you have to install the Linux dependencies, and then you'll be able to install this as the Linux commands. Okay, next thing, we'll have to copy the branch. Clone the repo. So git clone and that repo. And finally, to make this work, you'll have to change your profile. So again, depending on what type of machine you have, I have a Linux, so I get to the bash and git, and I have to modify my bash RC. But if you are using Mac OS, you'll where is it? you'll go here. So you'll go to the ZSHRC, and you'll have to add this line there. So depending on type of machine you have, you can follow that instruction. So in my case, I'll use this. I'll go to my bash RC. And here at the bottom, you can just add the ASDF line. And I think if you want to add completion, so it's kind of like autocomplete, you can pass this as well. Again, this is for Linux machines. For Mac, you go here. I save this. And now it's either you restart the terminal to make this working, or you just source the bash RC, the configuration file. And now if I type ASDF, I should have something like this. Everybody following along? If not, we also have like a video in the Basecamp session that we recorded online, and we also have the installation steps there, and we could probably send that in the 42 Discord channel. Cool. Now we have installed ASDF. From here, it's kind of like straightforward to install all of these. So let me grab this link. I'll go to Scarb and make sure that every library that you install, to install it with ASDF, it will make your life simpler. So to add Scarb, let me make this bigger. You have ASDF plugin, add Scarb. That's all the thing you have to do. This will clone the repo and will add it. Now I have to install Scarb. And in this case, I'm going to install the latest version. But depending on, I hope Charles will be working on the latest version. We'll see how to switch between these versions. So let me just install this. So this will automatically install the latest version, which is 2.6.4. I'm going to wait for a little bit. Maybe tell a joke or two. No? Whew. That's good. And finally, to kind of like set the version that you're using for Scarb, you'll have to say ASDF global and the name of the package, which is Scarb. And in this case, we'll say latest. So we'll say our latest version will be this. And now I can say Scarb and -- version, and I should have 2.6.4 installed. That's pretty straightforward. Now let's say that you're working on another project. Let's say you're doing Node Guardians. They're using a different version. They're using 2.5.3, right? And you have to downgrade. How to do that? You do ASDF, install, Scarb, and then instead of latest, you just say the version. You install this, and then you can set, again, the global dependency to 2.5.3. So, come on. Okay, ASDF, global, Scarb. And instead of setting the latest one, I'm going to say specifically to set it to 2.5.3. And now, if I say Scarb version, I should be on 2.5.3. So you see how easy it is to actually install these. And if you want to switch back, you just, instead of saying global 2.5.3, you just put latest. And then I'm going to say Scarb version again, and I'm back to the 2.6.4. So you see how easy it is to switch between these versions. Okay, Everybody following so far? Okay. Sorry? We do have a video as well. We can send that after this session and have it ready for you tomorrow. Okay, now let's take Foundry. Foundry is the library that has the testing suite available. And then this is also pretty straightforward with ASDF. You have ASDF plugging at Starknet Foundry. Let me start from scratch here. So I'll say ASDF plugin Starknet Foundry. I've already added it. And then you can install the latest, like this. It's going to take a bit. And now finally you have to set the global version. So to set the global version, actually it's not here, but we can do that. So ASDF global Starknet Foundry, and then say latest, because we installed the latest one. Okay, and now to actually check that this is actually installed, you call snforge -- version, and you should see the latest version installed. Starknet Foundry comes with two packages or two libraries. Is snforge, which is the testing or the testing library with unit tests and cheat codes and everything. And then there's also something called sncast, and you can do version as well. sncast is most likely CLI that allows you to declare deploy contracts on Starknet. So I'm hungry. sncast, like that. So it's a CLI that allows you to interact with the Starknet network or the block explorer, and you can declare contracts, you can deploy contracts, you can invoke contracts with sncast. Okay. And finally, I do need the VS Code. So for that, I need to install VS Code. VS Code. And for my machine, I need an ARM64. Yes. It's going to take a bit. Oh, thank you. Thank you. So VS Code, probably all of you already have it installed, but to kind of like get your syntax highlighter, you can go to this marketplace and download the Cairo 1. Let me check if I managed to download this. Software install, open. And the nice thing about it is that, for example, now I have Scarb installed, and you can say Scarb, new, and then you can create a new project here, and then let's say new 42 block chain. Again, I'm doing typos. So I cannot put digits, unfortunately. So let's say blockchain then. Okay, I'm gonna go into this folder. And let's see if I have my VS Code installed. I think I have it. Let's try to see code. I'll have to restart my terminal, I guess, because I installed. It's not found. haven't installed it, okay. Give it a second or two. I'll close my terminal. So we have it installed. I'm going to open it again because it resets the profile, so I'll able to call the VS Code now. Let me make this bigger. And now code dot. And now I'm going to open VS Code. I do trust the author. And currently you'll just see an empty directory. Or not empty directory, basically the standard. So we have a scarp toml file. Doesn't work. HDMI wanted to get out. I think we're, oh yeah, it's over 7 o'clock, so we have to wrap it up soon. So it just creates a standard folder. You have a scarp toml, which is kind of like your configuration for your project. If you want to have this highlighted, maybe just install a toml. TOML reader. I think it's called Even Better TOML, and then this will kind of like highlight your TOML. It's not necessarily, but to give it a nice overview. So if you go back, you'll see that we have some colors. It's just the package, and then here you'll learn more in the next session what this does. And finally, you have the Cairo file, which looks like this. It's a simple Fibonacci sequence. But let's install the syntax, the language server. So for that, it's Cairo 1. Make sure to install Cairo 1 and not any other Cairos. I see Charles having his own syntax here. So I don't know what he's cooking, but yeah? Nice. So install Cairo 1.0. And let's see if this actually works now. I might have to reload my VS Code, so let me do that. Okay, scarp is resolving, and voila, we have syntax. So these are all the things that you have to install and have it prepared for the next session. I believe that this session is recorded. You can always go back and see the necessary steps. If you have any questions regarding the installation and something doesn't work correctly, please reach out to me or to Charles or to anybody else, and we'll try to help you as best as possible. Yes? Code. I think we have the remix. There's you can do like work with Cairo as well there. And you can deploy your contracts, but it's just maybe for simple contracts. If you want to develop more detailed and complex projects, it's recommended to go to this route, but you can use the Remix editor. Oh, IntelliJ, okay. Yes, for IntelliJ, there's also syntax highlighter. I currently haven't used it. I heard that people use it and it works, and yeah. There's something available. But if you're using it, I can send you the links for IntelliJ as well. Any other questions? Well, with that being said, I think that's a wrap for this session. So thank you for listening to me. I hope it was exciting. And looking forward to the next session. Thank you.
I'd just like to say something really quick. Don't miss tomorrow's session. It will be the culminance of everything you've learned during the last 3 days, like the ultimate hands-on experience, and you'll be able to leave an I don't know how we say that, indelible mark on the blockchain. So yeah, it will be a cool session, and I think we'll have some fun. See you tomorrow.